Hello students, I am Professor Navneet Kaur from EC Department, SIRT Bhopal. Today I will be taking lecture on subject digital communication. The topic which I will be discussing here is eye pattern diagram. In this lecture, I will be discussing the basic concept behind the formation of eye pattern diagram. We will also study the parameters which are studied by using the eye pattern. Now first, we will see what is eye pattern. The eye pattern is used to study the effect of intersymbol interference in baseband digital transmission. Now, how eye pattern diagram is formed? A random binary pulse sequence is sent over the channel. The channel output is applied at the vertical input of an oscilloscope. A sawtooth wave at transmission symbol rate, which is FB, given by 1 upon TB, is applied at horizontal deflection plates. The oscilloscope shows superposition of several traces, which is input signal cut up every interval TB and then superimposed. The oscilloscope pattern thus formed looks like a human eye and hence the name eye diagram. Now here we can see that there are 8 basic 3-bit transition combinations that will create a eye. VOH represents a high voltage level used to represent bit 1, whereas VOL represents bit 0. So here we can see 8 basic combination formed by using 3 bits. So here we can see all the 3 bits are 0. Here all the 3 bits are high. Here we can see combination 0, 1, 1. Here 1, 0, 0. Again, in these 4-bit patterns, we can see total there are 8-bit patterns. Now, the resultant eye diagram is formed where 8-bit transitions are superimposed to create diagram, which we can see it resembles an eye. So it is known as eye pattern diagram. Here, as I already discussed, VOH and VOL, they represents high voltage level and low voltage level respectively. The eye height is the height of the vertical opening typically found in the center of the eye. So here we can see the eye height. Now here the effect of intersymbol interference is less, so the eye height is more. Whereas here we can see the effect of intersymbol interference is more, so the eye height is reduced. Now in the presence of channel noise, the eye tends to close. So thus we have seen in the previous diagram here that as the effect of channel noise dominates, the eye height reduces. The height of eye opening at specified sampling time is called margin over noise. The width of eye opening defines the time interval over which receive wave can be sampled without error from intersymbol interference. So here we can see the eye width. So in both the diagrams, here the effect of the channel noise is less, so the eye width is high. Whereas here the effect of channel noise is more, so there is less eye width. It is preferable to sample the instant at which eye is open widest, which is called best sampling time. So here, when the eye is open widest, we can see at the middle of the eye, this is the time which is called best sampling time. Now, coming to the parameters which can be studied using the eye pattern diagram. Now, first is the jitter. Jitter is the measure of the signal quality that is derived from the amount of variance in the signal's characteristics. Jitter is actually a timing error which results from misalignment of rise and fall times. When rise or fall time occurs at times that differs from ideal time, then there occurs a jitter. In the theoretical zero jitter case, all of the bit transition will lay perfectly on top of each other in the eye diagram for very precise transition times. The eye diagram edges will appear thicker because the signal is transitioning earlier or later in time relative to other bit transition when the jitter occurs. Second parameter here is transition time. Transition time is the rise and fall time that is associated with the signal, and it is measured using the rise and falling slope of the transitional signal in the eye diagram. A zero rise time will have a 90-degree slope. Faster rise times results in shorter transition times and more open eye diagram. Therefore, the digital signal will be valid for longer time during that bit period. The eye width measurement is typically used to analyze the quality of the transition time. The faster the transition time, the larger the eye width will be. In contrast, the slower the transition, the smaller the eye width will be. So here we can see how the eye closes up both vertically due to the signal swing diminishing and horizontally as the rise and fall times increases and transition times becomes longer. So there are many different reasons for eye opening to be reduced, and it is generally a channel noise. Parasitic effects associated with the transmission media, such as capacitance and inductance, are responsible for the majority of the signal noise. So the longer the transmission length, the more smaller the eye will become, because in this case, the effect of the channel noise will be more. So here we can see the well labeled and the detailed diagram of the eye pattern. Now, the parameters which are shown here is the first is the noise margin, which is decided by the eye height. Here, the noise margin is it reflects the noise which can be tolerated. It reflects the signal to noise ratio at the sampling point. Now here we can see the slope of the eye indicates the sensitivity to timing error. The smaller value of the slope will give the better results. Now here the variation at the zero line or the zero crossing, it indicates the jitter effect. So we can measure the jitter by taking this time variation. Now at the eye opening, this is the time which is the best time to sample. So here in the middle, it is the best sampling time when the eye is open widest. Now here we can see the amount of distortion which is set by the signal to noise ratio. So this diagram gives the detailed variations of the parameters which can be studied using the eye pattern. Now this is all for today's lecture. Thank you.